If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where we are solving previous year IIT JEE questions on complex numbers. So today we will be solving question number 22d, 23, 24, 25 and then up to 26. Okay, then let's try to solve these questions. Now if you come to D, again there will be the answer is wrong question. The question was set up as wrong. So again we will explain this one. The maximum value of this one they are asking. Argument of this one for z is equal to 1, z not be 1 is equal to argument of this one. Z is given this one, so 1 minus z is this one, so z is this one. So if you take the magnitude, because z was unimodular, they told you it is unimodular, so the modulus of this one is 1. So now you can think, so that means omega minus 1 mod is equal to omega minus 0. So it will be, you know, what is that this means? The distance from 0, 0, distance from 1, 0. So this is 1, 0 should be equal, that means it is a perpendicular bisector by these two. Okay, so that means your omega lies here from infinite to infinite. So now they are asking what is the argument of omega, the maximum value of this one argument, then what will be the maximum value, because we have taken this one omega, so the argument of this one is nothing but argument of omega. So what will be the argument of this one? Omega can be anywhere, so it can start from 0 and it can keep on increasing if you move on, but it cannot never reach on pi by 2. You can think of it will increase, but once it reaches pi by 2, then this will not be the line. Once it reaches pi by 2, because this was the line you thinking, this is increasing you theta, but once you reach pi by 2, it will come here, it will not be this line. So it cannot go pi by 2, it can go from 0 to up to pi by 2 in the positive direction, in the negative also 0 to minus pi. So if you take mod of this one, only positive values will come, and the maximum will go not up to pi by 2, but here it is given pi by 2, so that is given as option T. But anyway, you know it is not the correct one. The set of this is a complex number, this where z is not equal to 1. So if you go this one, modular z, again same formula. If it is given, I am tempted to this. So because it is 1 minus z square, I will use this theta, that will be useful for me. So I will apply this one, again 1 minus cos theta I will apply, sin 2 theta I will apply. So this if you cancel out and you take sin common, this one we have done so many times. So this is already real part. So we got only real values of, that is minus cosec. Okay, so minus cosec theta, what will be is range, the set, that is the output they are asking. So cosec theta, you know, it is either greater than 1 or less than minus 1. So it can go either way. So negative of that one is also same. Either it can go negative direction or it can be positive. If you take the negative of this one, it will come this side. If you take negative of this one, that will come that side. So everything will be same. 1 to infinity or minus infinity to minus 1. That is your option C, S. Now if you come to B, this one, the domain of this function. So domain means what value of x you can put it there. So what value of x you can, so this should be less than minus 1 to greater than 1, because in sine inverse you cannot put values which are less than minus 1 greater than 1, because sine is not defined there. We will see this one while we will see inverse function. So it should lie between these two values. Okay. Now here what I have done, I have tried with the options, but you can directly calculate using this. I have solved it here using this one. It will take some time, but you can use. So this should be less than 1. So you take 3 to the power x is equal to y. So one thing, once you take 3 to the power x, you should be careful. It should be greater than 0. That you have to be very careful. Now let's try this one. This one cannot be 0 because it is in the denominator. So y square cannot be 9. So y cannot be plus minus 3. Minus is already neglected because y cannot be negative. So it cannot be plus 3. That means your 3 to the power x is equal to plus 3. X cannot be equal to 1. So that is one thing we have learned from by seeing this one. Now once you know this one, you have to multiply both sides by this. So you don't know whether it is positive or negative. If it is positive, then the inequality sign will be as it is. If it is negative, then it will change. So you have to go by case 1 and case 2. This is case 1, case 2. Case 1 I have considered it is positive. So I can directly multiply, no change. It will be less than equal to, it will be also less than equal to. If you change this one, now there will be two equations formed. One will be this one will be this one. Both should be satisfied. If you do this one and this one, then if you put some folds, you will find these are the answer, these are the answer. So common of these two will be, here it is saying between minus 1 to 9, here it is saying minus 9 to 1. So common between these two is minus 1 to 1. That should also satisfy you this condition. This means y square should be, what does this mean? This means y square should be less than 9. Y square should be less than means y should be between minus 3 to 3. So this is also satisfying this one. So your case and your conclusion both should satisfy. So ultimately from this side you got this one. But again y cannot be negative. So negative portion is gone. So it should be less than 1. So So 3 to the power x is less than 1, 3 to the power x is less than 0, so x should be less than equal to 0. From here you got one range of x, that can be equal to 0. Another case was this was less than 0, that means either y should be greater than 3 or y should be less than 3. So if it is less than 0, then if you take product it will change. So less than equal to become greater than equal to, less than equal to become greater than equal to. Again two inequalities formed, again you can solve this one. Here you are finding 9 to infinity, minus infinity to the minus 1. So negative portion you forget because y cannot be negative. So let's concentrate on positive portion. 9 to infinity, 1 to infinity. So common is 9 to infinity. So that means y should be greater than 9. 3 to the power x should be greater than 9, 3 to the power x should be greater than 3 square, x should be greater than equal to 2. So if you combine these two, this is your domain. That is your option T. Now if you open the determinant, they have asked you to this determinant such that what is the value? Theta should lie between in first quadrant, then the set of f theta. If you take the determinant of this one, if you take determinant of this one, it is 2 sec square theta. So if it is between pi by 2, so you know the range of sec theta is this one. Sec square, negative values will disappear because if you take square, only positive values will come. So these will come. Everything coming below minus 1 will now become positive. It will go to 1 to infinity. And it is multiplied by 2, so it will go to 2 to infinity. So that is your option R. The last one, this one, the fx is increasing. So for increasing function, you have to differentiate it. Those who have don't know application of derivative will see it. If you differentiate it, 3 and x to the power n minus 1, this one, if you factorize it, this one. Now you will put pole. This is equal to 0, this is equal to 0, x equal to 0, you put pole, x equal to 2, plus minus plus. It is positive, so you need to write this one, but x cannot be negative, so this area will not come. So only this area will come, so it should be greater than 2 to infinity because they have given x is positive here. Okay, now if you come to 24, let z be a complex number such that the imaginary part of z is non-zero and this is real, then a cannot take value. Now this should be real. Now once you say this is real means, and z is a complex number, okay. So if you take this side now, that means a is real, okay. So if you bring this side, now if you see all the coefficients are real. So it is a quadratic equation whose roots are imaginary, not real. So its d should be less than 0. So this is the d that should be less than 0. That means your a should be less than 3 by 4. So you out of these options, all options are less than 3 by 4. Only one option, this d, it is equal to 3 by 4. It cannot be equal to 3 by 4. So that's why this cannot be the answer. Cannot be. That's why this is the answer. This is already I have covered in JEE main question number 10. You check that one. Now if you come to 26, let complex number this and these lies on two circles are given. x0, y0 center r, x0, y0 center 2r radius, and z satisfies a condition is given, then alpha should be equal to. Now I started with this way, but as I was not getting anything conclusive there, so then I thought of this one. Let me see what is the location of alpha and this one. Suppose one is z0, center is z0, 0, one is radius is r, one is 2. Now if I take alpha, where is 1 by alpha bar square? That was my intention to find. Whether it is in same line, suppose this is alpha, so this is your alpha from 0 if you connect. So where is your 1 by r? It can be anywhere in the circle. So to know this one, whether it is in same line or this one, if it is in same line, then we can do something because cos theta will involve mod alpha square. Mod alpha is this one. I need to find mod alpha. Okay. Because I can calculate cos theta here, I can calculate cos theta from here also. So if you see now this one, this vector is alpha minus 0. This vector is 1 by this minus this. If you divide these two vectors, take LCM, then alpha bar will come. Alpha bar by 1 minus alpha bar. What is alpha bar? Mod alpha square. So this is real, this side is real. When it becomes real? If these two vectors are parallel vectors. So obviously these two should be same vector because alpha is the common line, and if you need to, this is the common line. If you need to draw parallel to this one passing through this point, you should go this way. So this is the same line. If alpha is here, that means 1 by alpha bar is also here. So that is the beautiful thing. You have to think alpha and alpha bar, they lie on the same line, 1 by alpha bar. So once you know this one, then it becomes easy. Cos theta is equal to this square plus this square minus this square divided by 2 into this into this. So this is mod z0 square. They have also given z0 in terms of alpha. This is r divided by alpha into this one. Same for this triangle, now bigger triangle. This is 1 by alpha bar square, z0 square, and this one minus this divided by this. Now once you know 1 by alpha bar is equal to 1 by alpha bar is equal to mod alpha, that you know. So if you take alpha that side, so alpha bar and alpha is, and this alpha will also come upside. So this will be 1. because alpha bar will give you 1 by alpha bar, mod alpha into 1 by mod alpha bar. Alpha and alpha bar mod is same, so this will get cancelled, and you will left with mod alpha square. Once will come here, this, so square into this. This side it is same as it is. Now this is given, so you put it there. If you put it there, you will get beautiful things. R square will get cancelled out. You will get mod alpha is equal to 1 by itself. That is your option C. If you like the video, then press the like button and please give your valuable comments in the comment section.